Hello, thanks for joining me. Today we want to do some, I would say, some of the more difficult factoring a trinomial in the form ax squared plus bx plus c. So it's a trinomial, and the coefficient of x squared is something other than 1, so it's bigger than 1. And b might be positive, might be negative, c might be positive or negative. So I'm going to show you my method, which I've not been able to find here on the internet. I call this the 4-square method, and I did not invent it, but not seeing it around anywhere. And then I'm going to show you that this method that I use is essentially the factoring by grouping method. Okay, so let's get started. First of all, we have an example problem here, 2x squared minus 5x minus 3. The first step, and this is pretty typical, you'll see everybody says do this. Take the coefficient of x squared and the constant term at the end and multiply them together. So 2 times negative 3. So 2 times negative 3 is negative 6. Okay, and that's going to be a foundational number for us. And then we're going to do something that should be fairly familiar to us, find the factor pairs until we figure out which numbers add up to negative 5, then the middle term. So we multiply first coefficient and last coefficient, and then find the factors that add to the middle coefficient. So negative 6, let's see, that's negative 1 times 6, negative 2 times 3, negative 3 times 2, negative 6 times 1. I want you to observe how I do this. I just start with the smallest number I can think of, which is 1, or in this case negative 1, because I wanted to get a negative result, so a negative times a positive. So I start with 1 times 6, and then I go to the next number. I just do this mentally. Okay, 1, and then I try 2, and if it's not an even number, I try 3, and then I try 4, and I just keep on going until I have come up with my entire list. Then which number pair adds to negative 5, and you can see that it is the last two. Negative 6 plus 1 is negative 5. All the rest result in something else. All right, so now what are we going to do with those two numbers? I'm going to show you the little rectangle, the 4-square method. I don't even know what this is called. I haven't really thought of a name for it. But I'm going to put the first term in the first square, so 2x squared. And I'm going to put the last term in the last square, negative 3. And then I'm going to put the middle term, I'm going to split it between the two other squares. But here's how I'm going to do it. I'm going to split it using these two numbers. Remember, those are the two numbers that add up to negative 5. So if I want to split negative 5 into two numbers, this is one way to do it. And that's the way I'm going to do it. So negative 6x and 1x. I'll write 1x, but you know, normally we just write x. Okay, so I took my 3 terms and I split them up between 4 squares using that factor pair that I got from the first and last coefficient to give me the proper pair that's going to work here. Now I'm going to do this process. I'm going to look at each row and each column, and I'm just going to factor each row and each column, and I'll write the numbers down off to the left and at the bottom. Okay, so the first row between 2x squared and negative 6x, what's the common factor there? Well, 2 and 2, right, there's a 2 in each, and then they both have an x, so 2x. So 2x times x is 2x squared, and 2x times negative 3 is negative 6x. All right, now I'll do the second row. Second row, what do they have in common? Well, they have nothing in common. But they do have a 1 in common, right? We can divide them both by 1, so I'll just write a 1, and it's positive 1 because it's not even, like, they're not even both the same sign, so they don't have a negative sign in common. Okay, now I'm going to go down. I'm going to do the columns. So the first column, what do they have in common? Well, 2x squared and 1x, they have an x in common. And then the second column, well, notice the second column, they have a negative sign in common, so there's a negative. They both have a factor of 3, it's a negative 3. And there's my answer. One of my factors is 2x plus 1. The other factor is x minus 3. And that's my final answer. Let me write it here in blue. I'll just write it 2x plus 1, x minus 3. And there it is. Now, the rest of the examples I'm just going to do without all the explanation. I'm just going to go through the steps. I've got a bunch of examples, but real quickly I want to show you that this is really the grouping method. And the grouping method goes like this. You take 4 numbers, so 2x squared, and then you take that middle number, that middle term, negative 5x, and you split it up. So I'm going to split it in negative 6x plus 1x, then minus 3. So now I have my trinomial has been split up into a 4-term polynomial, and the middle term is that negative 5x has been broken apart into negative 6x and positive 1x. Now, and again, got those numbers in the same spot. Now I group the first 2 terms together, group the last 2 terms together. I factor out the first term. What's the common factor? 2x squared minus 6x, what do they have in common? 2 and x. And what's left over? We have x minus 3. And then for the second term, x minus 3, what do they have in common? Well, they've got nothing in common. So we say plus 1, right? Nothing is a common factor of 1. And then what's left over? X minus 3. So now I have an x minus 3 in each term, right? There's a term there and a term there. They both have an x minus 3. X minus 3 is one factor. And if I take those out, what's left over in the brackets, it's 2x plus 1. So there we have it, same pair of factors. This is the grouping method. The grouping method is really effective for a tricky or difficult trinomial where where a, the coefficient of x squared, is greater than 1. That method always works. Now, the nice thing about this is this method always works. It works for all trinomials that can be factored. So any trinomial that can be factored, you can factor it this way. So this is nice. You just memorize this one. Of course, all the other methods are a lot easier, but this method always works. So let's just practice. Now we're just at the practicing phase. I am going to do one last one with a little bit of a trick to it. It might be useful for you to stick around with. But for the rest of these, try it yourself before watching what I do. Okay, steps. We're going to first take the first and last terms, multiply them together. So 6 times negative 6 is negative 36. The factors of negative 36 that add up to negative 5. So let's see, negative 1 times 36, negative 2 times, let's see, what is that, 18, negative 3 times 12, negative 4 times 9, and I think we found it. Now, this isn't exactly right, but negative 4 plus 9 is positive 5, right? You add them together, get 5. So if I want to get negative 5, I just need to switch the sign. So negative 9 plus 4 is negative 5. So those are the ones I'm going to use, not the, but I knew I had it when I got a pair of numbers that add up to 5. I knew I was close. Okay, so let's get my little square here. First square, 6x squared. Last square, negative 6. Other two, the diagonal squares, are negative 9x and positive 4x. Okay, first row, they have a common factor of 3. 3 times 2 is 6, 3 times 3 is 9, and a common factor of 6, so 3x. Second row, common factor of 2. 2 times 2 is 4. 2 times 3 is 6. It's positive. First column, 6x squared and 4x have a 2x in common. Second column, two negative numbers, so if one's negative, one's positive, then we just say positive. But if they're both negative, then we say they have a common factor of negative. In this case, it's negative 3. So my factors are 3x plus 2 and 2x minus 3. All right, let's do that again using the grouping method. So 6x squared, pull it apart, negative 5x is negative 9x plus 4x, and then minus 6. Grouping, first two and the last two. Common factor is 3x, and that's 2x minus 3. Second pair, the common factor is 2, and that's 2x minus 3. I'm not even looking at 2x minus 3, 2x minus 3, does this work? This is kind of interesting. This isn't the kind of thing where you have to get here and then hope that it works, right? The grouping method, the when you have 4 terms, you do the grouping method. If it's like x to the third power and x squared and x to the first power and so on, there might be a question, is this going to work? But this method, you know it works if the 6 times 6, the factors of 6 times negative 6, if you have a pair that adds up to negative 5, then you know it works. So if you can find a pair, if you multiply the first coefficient, last coefficient, and then you find a pair of factors of that add up to the middle term, then you know that this method will work. Okay, so we factored out the common factor from each pair of binomials, and it turned out we are left over with a common 2x minus 3, and if we take out the 2x minus 3's, we're left with 3x plus 2. So there we have it. This works either way. Which way is easier? Well, it's up to you. It's whichever one you like. I kind of like the square one better, just because it pleases my visual sense. All right, let's do another one. 5 times negative 4 is negative 20. Factoring that, we get negative 1 times 20, negative 2 times 10, negative 3, nope, 4, yeah, 4 times 5, and we can see that that's it. Negative 4 and 5 is 1, so negative 5 times 4 would also be negative 20, and if you add those together, you get negative 1. So there's my two terms. I'll throw them into my 4 square boxes. 5x squared, negative 4, then negative 5x and positive 4x. First row, looks like there's a 5 and an x in common. Second row, whoa, it looks like there's a 4 in common. It's going to be positive because the signs are not the same. First column, looks like there's nothing in common except for an x, single x. Second column, looks like they're both negative, so it's negative, but there's no factors in common other than 1, so just x minus 1. So my answer is 5x plus 4 and x minus 1. Okay, now I'm trying to kill you with examples here just so you can see this being done swiftly and simply, and please watch this over and over again, watch it at slow speeds, try it yourself. I will, but maybe I'll tell you some of the secrets here. You want to test, if you want to test to see if this works, you just make up a problem. How do you make up a problem? Well, you just start out with a number that's more than 1, so like 2, and then you put a variable, let's say x, and then you just minus 7. Okay, and then another, maybe we'll try another number that's greater than 1. How about 3x plus 2? Okay, so there's my answer, And now in order to get the problem, I just have to FOIL, right? So that's 6x squared, and then plus 4x, and then minus 21x, and then minus 14, and then we'll combine those two, 6x squared minus 17x minus 14. Okay, this is the question, and the answer is, the question is, can you factor that? And the answer is, yeah, it's right here. So we know it can be factored. Right? If I just make up a random trinomial, there's no way that I know it can be factored, and that's another key thing to understand, that not every trinomial can be factored. But this method will tell you right up front if it can be. Okay, so if you want to practice this yourself, you just, you don't need somebody to give you a bunch of practice problems. You just make them up yourself. You just create them, and then see if these steps work. Okay, let's ask that question again right now. Can this be factored? 3x squared plus 8x plus 4. How do we know? We take 3 times 4. 3 times 4 is 12. And then we find the factors of 12 to add to 8. So 1 times 12, 2 times 6, 3 times 4, oh wait, 2 times 6, that's it. Because 2 plus 6 equals 8. At this point we know we have a pair of factors of the product of the first and last coefficient that add up to the middle coefficient, so we know that this will work. We can factor this. So now we've got to use one of our methods, either the grouping method or the 4-square method. 3x squared plus 4, and then we'll break that 8x into 2x and 6x. And is there a rule about which is which? No, it does not matter. If I swap these around, then the two factors would have ended up on opposite sides. That's it. So it doesn't matter which way I do it. Okay, so 3x squared and 2x have an x in common. 4 and 6x have a 2 in common, positive 2. 3x squared and 6x have a 3x in common. And 2x and 4 have a 2 in common, it's positive 2. So the answer is x plus 2 times 3x plus 2. Now again, when you're doing this and it's a test and it matters, whether it's part of a larger problem or you got to get it right because it's a test, please take the time to do the FOIL process with your answer to see if you get back to the original question, because it's worth it. Now maybe if you're doing a million problems in practice problems because you've got a really mean teacher, then maybe you don't check every single time. Maybe you check the answers in the back of the book or something. But this is a self-checking type of problem, so it's really good. Okay, I want to show you this one. I think it's the last one. I want to show you this one because there's a small trick here, just a really small one, on top of the fact that this got some ugly numbers here. 8 times 15, oh my goodness. Let's see, that's 30 times 4, that's 120. So 8 times 15 is 120. That's going to be a bear. Let's do it fast. 1 times 120, 2 times 60, 3 times, let's see, that's, let's see, that's 40. 4 times, let me give you my thought process here. I'm just trying to figure out, okay, so 120 divided by 3, well, 12 divided by 3 is 4, so it's 40. Now, instead of doing 120 divided by 4, I'm just saying, okay, 2 times 60 is 120. Half of 60 would be 30, so 4 times 30 is 120. Okay, now I'm going to do 5. 5 does go in there, doesn't it? So there's no easy way to do that. Let's see, it goes in twice. 4 times, okay, so 5 times 24. 5 plus 24 is 29, so we're getting close. Let's see, let's do 6. Instead of going back up to the 120, I go to the 3 line. 3 times 40, so half of 40 is 20, so 6 times 20. Okay, oh, and there it is. 6 times 20 is 120. 6 plus 20 is 26. Now that's not right. We wanted to get negative 26, so we'll just make them both negative, because negative 6 times negative 20 is positive 120, but negative 6 plus negative 20 is negative 26. Okay, now we're going to plug this into our squares. And this is where we have to be a tiny bit careful. Negative 6x, negative 20x. Okay, now watch this. What common factor in the first row? What are the common factors? Well, 8 is 4 times 2, 20 is 4 times 5. So they have a common factor of 4, and then they both have at least one x, so 4x. The second one, 15 and 6x, negative 6x, they're both divisible by 3, right? 3 times 2 is 6, 3 times 5 is 15, so this is just 3. And look at this. I said if one's positive, one's negative, then we just say, well, that's positive. Okay. We'll come back to that. That's a mistake. We'll come back to that. Let's keep on going. Let's just get our numbers in the right place. Okay, so 8x squared and negative 6x, so we've got 8 and 6 are both divisible by 2, and then there's an x in common, and then negative 20x and 15. I think there's a 5. Maybe, is that it? Yeah, okay. So, and again, the signs are different, so therefore, we said, let's just make it positive then. But here's the problem. If we said 4x plus 3 times 2x plus 5, well, 3 times 5 is 15, that's good, and 4x times 2x is 8x squared, that's good. But the inners and the outers are going to both be positive, so they can't add up to negative 26. And here's the problem. We said that there is no common factor of a negative in any of my rows and columns, especially my last row and my last column. But if you think about it as this was a negative times a negative, so negative factor times a negative factor is positive, right? So negative times negative, negative 3 times negative 5 is positive 15. That tricked us, or that threw us off. So here's the simple rule, but just understand that this is because that negative times a negative is positive. If both of these are negative, then both of these have to be negative. The factors have to both be negative. Because the only way that you get two negative numbers in the middle there is if you multiplied by some negative numbers. And then when you multiply the two negative numbers together, negative 3 times negative 5, you get that positive 15, and so that kind of fools us into thinking that it was a factor of a positive number. So watch out for that. That's the only tiny little trick that can throw us off. So now we know it's 4x minus 3 and 2x minus 5, and that is the final answer. Thank you very much for watching. Try these out. It takes a little bit of practice, and it comes really fast. Once you've done 5 or 6 problems, you will be able to do this in your sleep, and then you'll be able to factor any trinomial. Even the really, really simple ones can be factored with this method. Thanks for watching.